Hello, mathematicians. This is the video, let me get it here, for the second review sheet for Unit 2. And this is going to look just like the quiz that we take on Friday. So make sure that you are really focused and you're really thinking about the questions and how you're doing. And if you are feeling still a little stinky or a little fuzzy on any of them, try to watch that part of the video again and see if listening to it for another time will make it better. All right, here we go. 450. It says, how many tens is this? That basically means how many strips. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 strips. Another 10 would be 20. Here's 30. Here's 40 strips. 41, 42, 43, 44, 45 strips. And 45 times 10 is 450. How many ones is this? The answer is already written on the paper. If you were to count every single individual unit square, 100, 200, 300, 400, 410, 420, 430, 440, 450. There are 450 of them, and 450 times 1 is 450. All right, let's look at the next one. 290. How many tens is this? Is asking how many strips is this? We've got 10 strips. Here's 20 strips. 21, 22, 23, 24, 25, 26, 27, 28, 29 strips. And 29 times 10 is 290. If you were to count all of the units, all of the squares, all of the ones, there would be 290 of them. 290 times 1 is 290. All right, solve the following equations. All right, I am going to work smarter, not harder, and I am going to look for the basic fact, 5 times 9, and then I'm going to worry about the zeros. 5 times 9 is 45, and you know what to say. 1 on the left, 1 on the right. All right, next one. We've got 200 times, sorry, it's staying fuzzy. There we go. All right, 200 times 800. Sorry, guys, this won't focus. There we go. 2 times 8 is 16. And then let's count those zeros. 1, 2, 3, 4. 4 on the left, 4 on the right. 20 times 500, again, we're going to ignore those zeros and just find the basic fact. 2 times 5 is 10. And because 10 already ends in a 0, just be extra careful. And you might want to say 3 extra on the left, 3 extra on the right. So it looks like there's actually 4, but that's because this 0 was part of the basic fact. All right, this one's maybe a little bit more challenging. Again, ignore those zeros and think 4 times what is 36? 4 times 9 is 36. And then look at the zeros. There are 2 zeros in the answer, and there's only 1 0 in the problem so far, so I need 1 more 0. Let's count again. 2 in the problem to match the 2 in the answer. All right, these next 2 are basically showing break apart. And in the break apart method, you can break apart one number into 2 smaller pieces. So the first thing I want you to notice is that 10 stays consistent everywhere. So 10 is not the number that they're breaking apart. They're breaking apart the 13 into something and 3. And if you break apart 13 into a 3 and this would have to be 10. So here's what it's saying. Instead of doing 13 times 10, do 10 times 10 and then 3 times 10 and just put it together. And we don't have to figure out the answer. We're just figuring out like what goes in this blank. We don't have to figure out the final product. All right, this next one is also break apart. Notice again that 20 is staying consistent everywhere. So that's not the number they're breaking apart. And 20 is pretty easy to work with, but 47 is kind of odd and kind of weird. So they're going to break apart the 47 into a 40 and a 7. So here's what this means. Instead of doing 47 times 20. You could do 40 times 20 and 7 times 20 and just put it all together. All right, this last row, can you make sure that this says 5? I made a mistake and had to correct it. Make sure that says 5. So cross it off and make sure it says 5 if it doesn't. And we are not really having to find the answer. We're just going to make what's on the left side of the equal sign match what's on the right side of the equal sign. So here is my suggestion. Kind of go one thing at a time. I see a 5 on the left, and there's a 5 on the right. Check. I see an 8 on the left, so we need an 8 on the right. I see a 0 on the left, so we need a 0 on the right. And if you were to multiply 50 times 8, that equals 400. And guess what 80 times 5 also equals? Yep, 400. All right, so we're just kind of making the left of the equal sign look like the right of the equal sign. All right, I see a 7 on the left, so we need a 7 on the right. I see a 9 on the left and a 9 on the right. Check. I see a 0 on the left and a 0 on the right. Check. So 7 is what it should be, not 70, because these zeros are already kind of balanced out. We just needed that 7. And again, if you were to multiply the left, it would equal 630. And guess what? If you multiply the right, that equals 630 as well. But you don't have to. You can just make sure the left matches the right, and they will equal the same product. All right, on to the second page. Let's go ahead and multiply by using an area model, which is most kids' favorite. So we're going to do 11 times 34. So I'm going to do a 10 and one more. And I could go 10, 10, 10, and 4, but I'm just going to go ahead so I don't have a ton of sections, and I'm going to just keep it a 30. All right, so the numbers are bigger, but there's less sections, which is how I prefer it. All right, this first big section, 10 times 30 is 300. And 1 times 30 is 30. Gotta sneak that 30 in. 10 times 4 is 40. And the final corner, 1 times 4 is 4. And if you were to add all of these together, and you could do it off to the side if you need, that'd be 340, it'd be 370, 374. So the area model is actually quite similar to traditional that we'll learn later in the year, how your parents learned it, where it's basically making everything into easier steps, and then it kind of adds it all together. All right, repeated addition. We could do 52, 52 times, but that's crazy. So let's do 52 4 times instead. All right, you could do 52 twice and then double that. All right, my focus is all off. Thanks for hanging with me. All right. So I get 104, but that's only 52 2 times. I need 52 4 times, so I need to double that. You also could just do 52 plus 52 plus 52 plus 52, and you'd get 208 as well. Okay, so either way is fine, as long as you do addition of some kind. All right, the break apart method. I think 9 is already an easy number to work with. It's on our multiplication monsters, right? So I think instead of breaking apart the 9, I think you should break apart the 14. Now, you could break apart the 14 into a 10 and a 4, but I've kind of been digging breaking it up like this. But either way, it will work, and you should get the same answer if you break it apart into a 10 and a 4 or a 7 and a 7. And you just take one of the numbers times 9, then take the other number times 9. And again, no matter what, you should get 126 as your answer. All right, so it's okay if your break apart looks a little different, but your answer should be the same. All right, the ratio table. I would say the most important number is the number 13 because every student has 13 pencils. But I might use some of my ratio table kind of tricks for this. If you double the amount of students, you better double the number of pencils. Again, if you double the amount of students, you better double the number of pencils. And if I double 26, I get 52. If you double the number of students, you better double the number of pencils. Okay, I'm going to double one more time because look, if you double 8, you get 16. So if I double the number of students, I'm going to double the number of pencils. So that'd be 208. Okay, now notice that instead of 16, now it's down to 15. So they subtracted one student. And if you take away one student, remember how one student is 13 pencils? So if you take away one student, you've got to take away 13 pencils. So I need to do 208 minus 13. Oh my goodness, be careful with your subtraction. We've been working on it all year. 8 minus 3 I can do. I can't do 0 minus 1, so I'm going to make this a 1 to make this a 10. Now I can subtract 195. Okay. And we're going to do it one more time. If I take away one student, that means I need to take away 13 pencils. So I think I'm just going to use this and subtract 13, right? So I don't have to rewrite it. 5 minus 3 I can do. 9 minus 1 I can do. For a final answer of 182. Okay. All right, Carol's dollhouse is 4 times as tall as Kelly's. Kelly's dollhouse is 13 inches. How tall is Carol's? All right, so we are going to show a multiplication equation. And you could do 13 times 4. And you could use a variable, but I would also be okay if you put the answer there as well. All right. So let's figure out 13 times 4. You could do an area model. I know that's a lot of people's favorites. But because 4 is such a small number, I think I'm going to do 13 4 times and do repeated addition. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5. For a final answer of 52 inches. And again, I'd be okay with an equation that also had the answer in it. So either a variable or the answer. Just make sure you label it over here. Okay, if you did area model, you should have gotten 52 as well. All right, let's do one more with any multiplication strategy that we want. Valerie is building a new fenced-in yard for her chickens. The yard is 18 feet by 13 feet. This one seems to be a really good one, I think, for an area model. So we've got 13 on the side. We've got 18 across the top. And we're going to have these 4 sections. 10 times 10 is 100. 10 times 3 is 30. 10 times 8 is 80. And be careful, this final corner I feel like kids will mess up on. 3 times 8 is 24. And if I add all of the sections together, I should get 234 as my answer. Okay. All right, let's go ahead and write the equation. I should have done that first. 13 times 18, or 18 times 13, maybe you put, because that number was listed first. But either way, and you could use a variable, but it would also be okay to actually put the answer in. Okay, as long as you also have the answer over here, and we're going to write feet with a little tiny 2 to show that it's square feet. All right. All right, moving on. The last 4 are division problems, and we're going to do one of these 4 things with the remainder. All right, 6 kids share a package of 56 stickers. To be fair, they wanted to split them up evenly. All right, so we've got 56 stickers. Start with the bigger number. Divided between 6 kids. Okay. And we need to figure out the answer. So I'm thinking, what times 6 is as close to 56 as possible? And it would be 9. But wait a minute, 9 times 6 is only 54. Count up till you get to 56. It gives us a remainder of 2. Now, I don't think like splitting stickers, like ripping them in half is very appropriate. So I would just ignore the remainder and just say everybody gets 9 stickers. So on this one, I would ignore the remainder. All right, the White family bought a platter of 16 sandwiches for the game. The 5 people in the family were starving. How many sandwiches does each person get? So 16 sandwiches divided between 5 people. Think, what times 5 gets us as close to 16 as possible? 3 times 5 is 15. So there's 1 left over. So everybody gets 3 sandwiches, but there's this 1 sandwich left. Because they're starving, my guess is they're going to split that sandwich into fifths. Hold on, let me stop my phone for just a second because I'm recording a video. All right. So I would say that each person would be 1/5 of the sandwich, right? This would be 1/5. All right. So everybody gets their 3 sandwiches and they get 1/5 of their next sandwich. Okay. So it's like a little bonus bite. 3 1/5 sandwiches. All right. We've got 2 more problems. All right, here we go. Mrs. Mooney made 64 cupcakes for the party. The trays each hold 10 cupcakes. How many trays are needed to hold all the cupcakes? So 64 cupcakes, start with that bigger number, divided by 10, okay, into groups of 10. So what times 10 gets us close to 64? And it would be 6 times 10. 6 times 10 is 60. 61, 62, 63, 64. So there'd be 4 cupcakes left over. So what this means is you need 6 trays. But wait a minute. There's 4 cupcakes left over. So is 6 trays enough? Nope. Better round up to 7 trays. All right. So let's see. We round it up. We change that sandwich to a fraction. So this last one should be a money problem because we're going to change that remainder to a decimal. Okay, last one. Anne, May, Elizabeth, and Stuart grew pumpkins in their garden and sold them for Halloween. They made $50. How much money will each kid get? So $50 divided between 4 kids. Think, what times 4 gets us as close to 50 as possible? And it's 12. 12 times 4 is 48. 49.50. So we have $2 left over. Now, everybody's going to get $12. But what are you going to do with those leftover $2? If it's helpful, you could totally draw it out, right? And if you had $2 left over divided between 4 kids, each kid would get half of $1, which of course is 50 cents, right, per kid. All right, so imagine splitting up these dollars like into quarters, and each kid would get 50 cents or 2 extra quarters. All right. So not just $12, but $12.50. All right, here are the answers. Let's see if I can get it to focus. All right, page 1. Page 2. And page 3. All right, I hope you feel like you did very well. I'll see you in class.